A number of different parameters, financial, scientific or environmental, may be used to quantify the size of the global economy. Each of these parameters describes a different aspect of the economy, and there are advantages and disadvantages to using each. Within the study of economics and economic activity, GDP per person in constant dollars is often used. In our explorations here, we will look at three of these parameters for their usefulness in measuring the size of economic development over time. It is likely that the growth of the economy will follow the natural growth law, where the rate of growth of an object is proportional to the size of the object. This slide shows three different graphs as examples of the natural growth law, using different values for the exponential growth rate constant k. Here we will use the working hypothesis that the Industrial Revolution started in 1800 and that the global economy is growing in a simple exponential manner since then. We will develop simple mathematical models using this working hypothesis. At this stage we do not know the value of k for our simple models of the economy, and our next effort must therefore be to determine the value of k. The mathematical equation that describes the natural growth law is very simple. Basically, a multiplier that increases over time is calculated from the exponential function, and this is used to multiply the starting size of the economy. The size of the global economy in 1800 was significant, as several European countries had colonies abroad that gave rise to global trade and commerce. In that case, the equation that describes the evolving size of the global economy is E sub n is equal to E sub 0 by the exponent of nk, where E sub 0 is the size of the economy in the year 1800. N is the count of years since 1800. K is the exponential growth constant for the equation, and E sub n is the size of the economy in the year n. There are many difficulties in selecting an economic parameter to quantify the size of the global economy at any given time. In particular, the value of the parameter selected must be calculated for each country, with due regard to the population of the country, with regard to the exchange rate for its currency, with regard to the standard of living in the country, and with regard to the government intervention and controls of the economy. Some countries are more adept at providing reliable statistics from which the GDP and GNP for that country may be calculated. The net effect is that there is significant uncertainty in the summation of the sizes of the individual national economies to give an overall size of the global economy. Further, different international bodies, such as the International Monetary Fund, the World Bank, and the CIA World Factbook, agglomerate these data in different ways and over differing time periods. Without going into the details of economic terms, Wikipedia used the term gross world product to be the gross value of all goods and services produced on Earth. In our model, we will use the reported values for the gross world product for the years from 1800 up to 2010 that are in the table in the article. These data are reported in constant 1990 international dollars for each year up to the year 2000. Type wikipedia.org as the URL address required. On the Wikipedia homepage, type gross world product as a search term and hit the search key. There is a large amount of information on the page returned, with links to numerous articles and other references. It is worth exploring the valuable body of knowledge that is accessible from this page. However, we are primarily interested in the numerical data for the gross world product for the years from 1800 to 2010. We will select these data from the table by scrolling over the date of interest while holding down the left mouse key. We will only select data from 2000 back to 1800, as these data are in constant 1990 international dollars, whereas the data for the year 2010 are in different units. The highlighted data are then copied into the clipboard by hitting the Control Insert keys. We now move to Microsoft Excel and insert the data from the clipboard into Excel by hitting the Shift Insert keys. At this stage, we are in a position to examine the data in graphical format. From the Excel menu, select Insert, then Scatter, and then Scatter Only with markers. A scatter plot of the gross world product will be displayed. It is clear that the economy has grown dramatically since 1800. Indeed, it has grown from approximately $175 billion in 1800 to over $41,000 billion in the year 2000. We again look at the equation to refresh our memory. We only need a value for k, the exponential growth rate constant, to create a simple exponential model for economic growth in Excel. In our calculations here, we will presume that the growth of the old social and economic structures are negligible compared to the rapid growth rates in the new technical economic structures. We will store the value of k in cell D1. We will make an initial guess for the value of k, setting it equal to 0.01. Next, we will construct the model. The reported value for the size of the economy in 1800 is shown in cell B19. It is $175.24 billion. We will enter 175.24 in cell C19. Next, we will set the formula for the year 1850. The data for that year are in row 18 of the table. We note that the value of E sub 0 is held in cell C19 and that the value for k is in cell D1. The value for n, the number of years since the start of the model, is calculated as A18 minus 1800. Translating the exponential equation into the format used in Excel, we set up the formula in cell C18 as equal to $C$19 star exponent open bracket A18 minus 1800 close bracket star $D$1 close bracket. Absolute addresses are required for C19 and D1 in the formula so that these remain fixed and going up and down through column C. The formula in the cell C18 is copied to the clipboard by highlighting that cell and hitting the Control Insert keys. The formula is then copied up through the cells through column C by highlighting the cells C17 up to C1 and hitting the Shift Insert keys. So now we have the reported data from Wikipedia for the gross world product in column B, and we have the calculated values for the gross world product from our simple exponential model in column C. We can now compare these two sets of data graphically by highlighting columns A, B and C and preparing a scatter plot as before. The data from Wikipedia is shown in blue. The data from our model is shown in red. It is clear that there is little agreement between these data sets when k equal to 0.01 in the model. We can easily change the value of k by changing its value in cell D1. Setting k equal to 0.02 causes the difference between the data sets to decrease, at least up until the year 1950. After that, the gross world product rises much more rapidly than predicted by the exponential model. We may again adjust the value of k. Setting k equal to 0.025 gives better overall agreement. However, the model then overpredicts the size of the gross world product up to 1970, and thereafter it underpredicts the size of the economy. Setting k equal to 0.0255 gives closer approximation in recent years. Finally, we look at the fit when k is equal to 0.027. It is clear that the simple exponential model for the growth of the gross world product is a reasonable first approximation to the data reported in Wikipedia, based on a visual inspection of the plots. However, the model is far removed from giving an excellent fit to the observed data. So we will now proceed to examine another parameter.